Hey, what's up, my little Pythagoreans? We are going to talk about triangles today. And we're going to do some review trigonometry that I'm sure all of you will love. This is going to be a lot of stuff that you kind of learned in maybe Algebra 2 or Geometry, but you're going to need it again. So we're going to teach it to you again, just in case you, hypothetically forgot something. So here we go. Okay. So let's start with just some basic definitions for right triangles. Disclaimer, if you have a non-right triangle, like that bad boy, this stuff, you can't use it. It's forbidden. It's against the rules. You gotta, I asked your mom and she said no. She didn't sign the permission form, so you're stuck and you can't use it. So this stuff is only for right triangles. So there is, for a bunch of reasons, right? Right triangles, if they have the same two angles here, they're similar. And that means the ratios of their sides are equal. Okay, it doesn't mean their sides are the same length, but the ratios are the same. So some super smart math dude came up with 6 trig ratios that will help us solve for missing sides of triangles. Okay, so there is sine, cosine, tangent, cosecant, secant, and cotangent. And you're going to say, Barton, why did you put these 3 out of order? For some unknown reason. I'm sure there's a good reason. Actually, knowing mathematicians, probably not. It's probably because they, sine and cosecant are the ones that go together. Cosine and regular secant are the ones that go together, and tangent and cotangent. So these ones kids get mixed up all the time because they think cosine, cosecant. That's not the case. It's sine and cosecant, cosine and secant. Regardless, these are the trig ratios that you need to know and memorize for the rest of your life. Now would be a good time to ask your mom to get a tattoo. If you just got one, hypothetically, of like a little nautilus or something, ask for another one. Your mom's already cool with it. Tell them you need to get these fractions tattooed somewhere on your body, hopefully with this triangle for reference. So sine is opposite over hypotenuse. So let's just break this one down and then we'll run through the other 5 real fast. This is sine of theta. First of all, the theta is inside of the sine. It is not sine multiplied by theta. That's wrong and not what it is. Okay, you need to understand that the sine is inside, backwards. The theta is inside of the sine. It's like the square root of theta. You don't say the square root times theta. It's the square root of theta. It's sine of theta. The theta is inside the sine. And now you're going to say, what the heck is theta? Theta is a Greek letter, and this is just the variable we use for angles. It's just the variable we use for angles. It's like x or y. You can put x or y here instead if you like it, but most people use theta because everyone uses theta, so it's a good thing to use, So sine of theta, not sine times theta. So sine of theta is equal to opposite over hypotenuse. What this means is that the side that is opposite of the triangle from theta. So you have to know where theta is. If theta is down here, that's different than having theta up here. You get 2 different signs and everything changes. So you need to know the location of the angle to start with. It's saying if you go straight across from whatever angle theta is, that is your opposite side. And then your hypotenuse is always the one straight across from the right angle. I apologize if I'm belaboring this and you're like, no, I know this. Shut up, Barton. But some kids don't. So sine equals opposite over hypotenuse. That means that this side length, let's say it's 3, over this side length, 5, If you know these two side lengths, it can tell you what theta is. Or if you know theta and you know this side, you can figure out what this side length is. So it lets us solve for either angles or side lengths. Cosine is adjacent. So one of the sides that makes up the angle theta. One of them making it up, and hypotenuse, that's cosine, adjacent over hypotenuse. And then tangent is opposite over adjacent. Opposite over adjacent. Cool. So you're basically just going to fill in these fractions and maybe use the angle, and you're good to go. Cosecant is the reciprocal of sine. Let me write that out. Sine of theta to the -1 power, not the inverse of sine, meaning the reciprocal, meaning 1 over sine of theta. That's cosecant. Okay. The reciprocal of cosine is secant. You can see how adjacent and hypotenuse just swap places. And then tangent, opposite, and adjacent are swapped as well. Okay, so here's your 6 trig functions. Sine, cosecant are reciprocals. Cosine, secant are reciprocals. Tangent, cotangent are reciprocals. Here's the sides. Cool, we're good. That's review from geometry, I hope. If not, sorry for rushing it. All right, we're going to use what we just learned to solve for x. So when you are doing problems like this, you need to know where theta is, and the thing that I recommend you start with is labeling your sides opposite, adjacent, and hypotenuse, and that will really mitigate the mistakes. So here's your right angle. That diagonal side, this is your hypotenuse. This is the angle we know, so this is theta. So we need to base the opposite and the adjacent off of that. So going straight out of this thing, this side is the opposite side. And then, oops, I've drawn too much. And then the side that helps make this angle, whoops, sorry, pressed a button, whoops, sorry, is the adjacent side. Okay, so we need to use the angle, 60 degrees, and then we need to find the trig function that uses the information we know and the information we're looking for. So you need to ask yourself, which trig function has adjacent and hypotenuse in it? Think about it. Ah, very good. Cosine. So cosine is adjacent, which we don't know, x, divided by the hypotenuse, 10. Now we can solve for x. We can figure out this missing side. To figure this out, you need to plug this into your calculator. Cosine of 60, that's some weird number. Let's type it in. You probably want to make sure that your calculator is in degrees and not radians. Otherwise, you might get the wrong answer here. So let me just type this in super duper fast. Hold on, hold tight, just a second, don't rush me. And you get 1/2. I should have known that. That's embarrassing. So cosine of 60, that's 1/2. Your calculator will tell you this as long as it's in degrees, not radians. You can usually tell at the bottom of your calculator, like you're looking at the screen here, it'll either say deg or rad. Whichever one it says, that's what it's in. If it says deg, then it's in degrees. If it says rad, it's in radians, you need to change it. So you type in cosine of 60, and you don't have to put the degree symbol, just make sure it says degrees. And hit enter, it'll say 1/2 equals x over 10. Now we solve for x, so we multiply both sides by 10 to get rid of this divide by 10. So we get 10 over 2 equals x, and 10 divided by 2 is 5. And that's really all you need to do to solve those triangles. Good? Think we can handle that? Tight. Okay, let's go look at another type of question. All right. The next thing we need to know is Pythagorean's Theorem. And I'm sure you learned this in like kindergarten or something like that, but in case we didn't. Pythagorean theorem says a squared plus b squared equals c squared. A and b are actually interchangeable. It doesn't matter what they are. The only one that matters is c. C has to be your hypotenuse. A and b are what are called legs of the triangle. They're the two sides that make the 90 degrees. So if you say A is 9 and B is 10, and you accidentally get these two switched and you put like 10 squared plus 9 squared equals c squared, it's not going to matter. A and B are switchable. The only one that really matters that you don't mess up is C. It has to be the hypotenuse. Okay, so this should be review, hopefully. And then at the end of the lesson, I have a story for you. You're going to love it. I drew like a little thing of pictures. You're going to love it. It's great. But let's go do some practice with our Pythagorean theorem. So here's what they're going to tell you to do. They're going to say, find every trig ratio. So they're going to have you fill out sine of theta, cosine theta, tangent theta, cosecant, secant, and cotangent. Hang on. Hold up. Just one moment. Give me a moment. Sorry. Apologies, ladies and gentlemen. My dogs just got home, and I don't know who raised those things, but they have no manners whatsoever when it comes to not interrupting people's lecture videos. So as I was saying, we're going to find all 6 trig ratios by looking at this triangle. So the first thing we need to do is we need to find this missing side right here. And maybe even the real first thing we do is label these opposite, adjacent, and hypotenuse. So here's theta. We cannot do this unless they tell us where theta is. So our opposite side is going to be the unknown one. Here's the right angle. So our hypotenuse is the one labeled 5. And our remaining one is the adjacent here where the 3 is. So now that we have that labeled, it'll make it a little bit easier for us to find our trig ratios. But first we have to find the missing side x using Pythagorean's theorem. So we want to take our adjacent and opposite sides. These are A and B, or B and A. It doesn't matter which is which. So 3 squared plus x squared equals our hypotenuse, 5 squared. So 3 squared is 9, plus x squared equals 25. Subtract 9. X squared is 16. And this is where a lot of students stop. They say, oh, x is 16, we're done. Please make sure you take a square root of both sides. This is a huge mistake that people make very often. So square root of x squared is x equals 4. And because you guys are super, super diligent students, I can feel it inside of you. It's screaming to get out. Mr. Barton, you forgot the plus or minus. We took the square root. You told us anytime there's a square root, you have to do the plus or minus. Okay, listen, kid, don't trip out. Look, you think I would just forget something like that? And if you just said yes, I swear to gosh. So let's talk about why we only care about the positive one. We are looking for the length of this side. Is it possible to have a negative length? Can you be negative 4 feet tall? No, that's silly. You can't have that. So because this is sort of a real life thing, it's a real triangle we can draw, you have to make it a real life thing, right? You can't be negative 4 feet long. You have to be 4 feet long, and we'll ignore the negative. That's sort of, but it makes sense if you don't think about it too hard. All right, so now we know that x is 4. Now it's smooth sailing once you're done with the Pythagorean theorem. We're just going to plug all of our equations in to sine, cosine, tangent, and then we'll flip them for these. So sine is opposite over hypotenuse. Let me make this a little bit skinnier. There we go. Opposite is 4, and our hypotenuse is 5. Sweet. Cosine is adjacent over hypotenuse. So 3 over 5. And then tangent is opposite over adjacent. So 4 over 3. Now to get the reciprocal trig functions, we just do the reciprocal. So we're going to take all of these fractions and flip them upside down. So this is going to be 5 over 4, 5 over 3, and 3 over 4. And there you go. You filled out all 6 trig functions and you did Pythagorean's theorem. So I believe that's all you have to learn today. Let's go talk about a story. So this is one of my all-time favorite stories of mathematics. When I heard this, I laughed for so long. This is one of my favorite stories. It's a great story. I'm going to tell you the legend of radical 2. So a very long time ago, if you're done watching notes, you can be done. 15 minutes, that's good enough. Get out of here. If you don't care, go do your homework. I'm probably only going to give you 16 minutes to do the notes anyway. This is extra for the kids who care. So a long time ago, there was a group of people called the Pythagoreans. Oh, I wonder who was in charge of those dudes. Some people don't think that Pythagoras was a real person and that Pythagoras was just like a pseudonym for anyone who was in this cool club of Pythagoreans. Fun fact, the symbol of the Pythagoreans was this. Bum, bum, bum. I knew math was evil. But yeah, the Pythagoreans had a pentagram as their like club symbol, which is kind of cool. So there is this nameless Pythagorean. His name was lost to history. Unfortunately, we don't know who he was or anything, but we know we have this story about him. So one day, this man had the audacity to say, if I have a right triangle whose legs are both 1, how long is the hypotenuse? And we know now 1 squared plus 1 squared equals c squared. So 1 plus 1 is 2. Whoops, sorry, I spoiled it. Is c squared. So 2 equals c squared. Take a square root. C equals the square root of 2. But this was a problem for the Pythagoreans because the Pythagoreans thought that irrational numbers didn't exist. They thought any number could be written as one number over another one as a fraction. And we know radical 2 is irrational. It's 1.4141592 something. That might not be right. The 414 is, but I don't know if the one. Anyway, I digress. It's irrational, nonetheless. It's a decimal that cannot be written as a fraction. So this was bad because the Pythagoreans thought that numbers were given to them by the gods, right? Zeus himself gave them numbers, and they were perfect. They were discrete incremental things that could be put into integer numbers of things. It's an integer number of things cut up into an integer number of groups, right? And if you can't write it that way, the Pythagoreans said, you're stupid. That's dumb. The gods wouldn't make imperfect things like that abomination. So the Pythagoreans argued amongst themselves. Again, no, this guy's an idiot. But this man came up with a proof. And I'm not going to show it to you because it's kind of whatever. Like, it's cool if you're into that sort of thing, but you're not. So I'm not going to bore you with it. So the Pythagoreans got mad as heck. They said, the audacity of this man. So they hatched a plan. They asked the man, hey, you want to go with us on a sweet boat ride? Hey, bro, you got a sweet idea there. You want to go on a boat ride with us? And this dude's like, tight. Yeah, I love boats. HMS Maths. How tight is that? So these two dudes take our unknown hero and they say, let's go on a boat ride, bro. So he willingly accepts. He says, I love boats. I've loved boats since I was a kid. Boats are tight. So they go on a boat ride. Once they get out there, they grab this dude and they yeet him into the ocean and sail away. They murk him. They said, come up with an imperfect number, you thought, and they kill him. And that's the story of the first person ever to be killed because of math. So, yeah, that's the story. That just goes to show you, don't mess with math, kids. It'll get you killed. So, hopefully that was a good story. Hopefully you appreciate the little drawings. Make sure you like and subscribe. Patreon, support the channel, all that good stuff. If you have questions, let me know. See you later.